Alright guys, this is 3.2 part 2. We left off video 1 with the remainder theorem, which stated if a polynomial f of x is divided by x minus c, then f of c is the remainder when we do that operation. So let me give you an example here of how the remainder theorem works. Okay? So let f of x equal x cubed minus 3x squared plus x plus 5. And let's use the remainder theorem to find f of 2. Alright? Well, by the remainder theorem, we'll say x minus 2 on the outside, and then on the inside we of course have x cubed minus 3x squared plus x plus 5. Okay? So we're going to use this remainder theorem to find f of 2. Now let's go back and read it again. Polynomial f of x is divided by x minus c. So we have our x minus 2, and in this case the 2 is the c. Then f of c is the remainder. Alright? So we can, obviously we could just plug 2 in and find that, but this is an example of using the remainder theorem. Alright? So, x goes into x cubed, x squared times, which leaves us at, multiplying that, x squared times x is an x cubed, minus 2x squared, change your sign, so you get a negative x squared plus x plus 5. X goes into x squared x times, so we get negative x squared plus 2x. Changing your signs again, leaves a negative x plus 5. X goes into negative x, negative 1 times. It's a negative x plus 2. Change your signs and you get a remainder of 3. So by the remainder theorem, f of 2 should equal 3. Let's double check our answer. If we plug 2 into f of x, we should get 8 minus 12 plus 2 plus 5. Does that look right? 8 minus 12 plus 2 plus 5. Yeah. So, and this does in fact equal 3. Alright? So that's kind of the idea on how the remainder theorem works. Alright. Now, we got another theorem called the factor theorem. Right? It says this. It says a polynomial f of x has a factor x minus c if and only if f of c equals 0. We're going to prove this theorem using the remainder theorem. Polynomial f of x has a factor of x minus c if and only if f of c equals 0. So here's your proof. It's a pretty short one, not too bad. By the remainder theorem, we know that f of x equals x minus c times some quotient plus f of c. That's exactly what our remainder theorem is telling us. Right? If f of c is 0, it implies x minus c is a factor. Since we would then have f of x equals x minus c times q of x plus 0. Right? Going the other way, because it's an if and only if statement. Assuming x minus c is a factor, right? This implies that f of x is divided, or f of x divided by f of c x minus c, leaves a remainder of 0, which implies that in fact f of c also equals 0. Alright? So, factor theorem says a polynomial f of x has a factor x minus c if and only if f of c equals 0. Using the remainder theorem, we can say f of x equals x minus c times some quotient plus f of c. Right? Because it tells us here, f of x divided by x minus c, f of c is the remainder. So we have f of c in the remainder spot. If f of c equals 0, then certainly x minus c divides f of x. Going the other way, if f of x is x minus c is a factor, then f of x divided by x minus c leaves a remainder of 0, which again implies f of c equals 0. So that's your factor theorem. We're going to use that in an example here. Maybe it'll be clear to you how that should work. Alright, example. Show x minus 2 is a factor of f of x equals x cubed minus 4x squared plus 3x plus 2. Alright, so here's our solution. Well, we know that f of 2 equals what? Well, it equals 8 minus 16 plus 12 plus 2. Plus 12 plus 2, did I do that right? Plus 6, sorry, plus 6 plus 2. Well, this certainly equals 0. Right? So what this says is x minus 2 is a factor by the factor theorem. Okay? So going back to your factor theorem. A polynomial f of x has a factor x minus c if and only if f of c is 0. X minus 2 is a factor of this if and only if f of 2 equals 0. And it certainly does. So this is a shortcut that you can use when you have something like this to decide whether or not it divides evenly. Alright, let's do another example. Find a polynomial of degree 3 with zeros 2, -1, and 3. Right? So this is all the information we're given. We're going to find a polynomial, third degree, and it has zeros 2, -1, and 3. Well, what do we need to do? Well, by the factor theorem, f of x has factors x minus 2, x plus 1, and x minus 3. Well, how do we know that? Well, we're told these are zeros, which means if I plug them into the function, I should get a 0. So we know these three are factors of f of x. Thus, f of x equals x minus 2 times x plus 1 times x minus 3. But I'm not going to work all that out. Certainly there could be a constant variable up front, but it still doesn't change what the polynomial actually is. Alright? Multiply that out in your spare time. I'm not going to do it here. Okay? So that's the factor theorem. So, up to this point we've had the remainder theorem, we've had the factor theorem, we've talked about long division, we've covered pretty much everything I want to cover for these first two videos. So this covers basically the first half of section 3.2. I'll probably post one more video that'll finish out 3.2, and that'll be on synthetic division.